So the question arises as to why light is changing its path, changing its course. You just try to think about it. Why does this light ray changes its course? And when the paperweight was removed, once again light passed through the line as before and fell on point A. So I can say that this glass block is responsible for the deflection of light, and there are two separation surfaces here, one from air to glass and then again from glass to air. So light is deflected twice. This path was followed, and this is called the refraction of light. And if you study you look at this picture, this is a medium. Suppose this is air and this is a medium. Suppose this is glass, and this is the light that fell on this point of incidence, and this is the light that gets refracted to this point. And we knew from the rules of reflection that this incident light forms an angle with this on this point of incidence. If a normal is drawn, and it forms an angle with that normal, that is called the once again this is the incident ray, and this is the refracted ray, and this is the point of incidence, and it is marked by O, and this line is the separation surface, EF line, on which on the O point this incident ray falls and get refracted to the second media through this path. And the incident ray, and there is a rule of refraction, that is the incident ray this, and the refracted ray this, and the normal this. This is the normal to the surface of separation. This incident ray, the refracted ray, and the normal to the surface of separation of the two media at the point of incidence lie in one plane. This line, and this line, these three lines lie on one plane, and the incident ray incident ray and the refracted ray are on the opposite sides. In case of reflection, we have seen that it falls here, suppose it bounces back towards this direction. But in case of refraction, this falls on this point to this direction, and then it is refracted on the opposite side of the normal. This is the normal, this is the normal, this is the normal, and on the opposite side of the normal this is refracted. And so the ratio of the angle of incidence, this is the angle of incidence, this is marked by I. Actually it is called sin I, you will know it later. And this angle of refraction, it is called R, and the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant. It does not change, which depends upon the nature of the media and the color of light used. In every case, if you use a glass for refraction and if light is allowed to fall from the air medium to the glass medium, the angle of incidence and the angle of refraction will remain the same everywhere, each time. The ratio of this angle and this angle is fixed. This is called refractive index. Here you see, and again we should consider some more things. So this is the air medium, and this is the glass medium, and this is denser. Glass is dense, but air is light. From lighter medium to a denser medium, light is refracted. When such thing occurs, then the refracted light goes away from this normal. This is the normal, and this has been extended to this part, and from light comes to this point. On the point of incidence, an angle is formed here, but after refraction, this light, if the glass was not there, the light could pass through this line, but as it passes through the glass, it moves from this line to this line. But this ratio of the angle of incidence and the angle of refraction, that depends on the color of light and if there is no mention of any color of light, in that case, when we say about this ratio, we will mean the middle color, that is yellow color, the refraction of yellow color.